Okay, so my first question here is where do I go through the pole? And what that question means is really rephrased, when is the radius 0? Today our goal is to find areas of loops, but you can only find the area of a loop or a pedal, if you want to call it a pedal, if you know when it starts and when it ends, which is kind of like your polar discovery thing that I'm asking you to write up on. Let's make that due Friday. How about that? Sound good? Okay. But the whole thing is I need to know how many pedals I have or how many loops I have and when I enter and exit a loop. So that's why they asked the question, where do I go through the pole, which is some of your homework from last night. So this is rephrased as where does R equal 0? So if you want, we can do that. We can go, okay, 0 equals sine of theta, 2 cosine of theta plus 1. Okay? So then now I got two stories here. Sine of theta equals 0, or I have 2 cosine of theta plus 1 equals 0. Sine of theta equaling 0, that happens when? 0, 180, 2 pi, 360. If you want to say pies and 2 pies, that's awesome. I'll say degrees just to help you visualize. What are we going to be doing the math in, though? Radians. Are you guys okay? That I could have written pi and 2 pi, but I'll keep it as degrees for now, just so you can see me rank this a little bit better. Okay, next one then. This is saying when does cosine theta equal -1/2? And in the world of cosine, cosine is x. It's those moments when x is negative and short. So that happens at 120 degrees and 240 degrees. And my screen is way off again. Okay, so from that, what I want you to realize is this. I am going to order your moments. So I start at 0 degrees. I'm at the origin. I go through the origin at 120. I come back out of the origin at 180. I go back in at 240. And then I leave at 360. Okay. Are you okay with me orderizing it that way? Ordering. Thank you. Okay. Now, let me zoom in. I zoomed in and took a picture of this. Could you easily graph this on Desmos? I zoomed fully in on the origin, and this is what I got. And I want you to understand what I have here. Okay, think of like tangent lines. You know when we talk about tangent lines in Calc 1? Like a tangent line in Calc 1, I could have a parabola, but if I want to stare at that dot, if you zoom in, what's that dot going to look like? A line. You guys okay with that? The zoomed in version of that, you get the line. Okay? So if I zoom in on the origin and zoom in anywhere on a graph, doesn't it turn linear? Okay, that's the whole idea of like a local tangent line. So let's see if I'm right. So I told you it's going to have exit strategy at 0. Does it? Look at my order, 0. Where else does it happen at? 120. Do you see this line at 120? Okay. And then I have one at 180. And then I have one at 240. And then I have one at 360. Now, the two lines that you might go, wait a second. What else does it look like I have? 60 and 300. Let me color this like purples. The reason is if you enter, let me draw a thing here. Let's say you enter at 120. What's going to happen at 120 when you enter? Does it just do that? Can it do that? No, because it has to be smooth on its transition. So it can't do that. It's going to loop through. Do you see when it loops through, it looks like it's going on the purple part? remember 120, the whole line of 120 is here and there. What does that mean at 120? This is maybe where you're looking. You might be looking this way, but can you also have eyeballs looking the other way? Because, okay, it's like a line at 120 goes second quadrant and fourth quadrant. Guys, okay with that so far? Question? Looping through and an exit point? Okay, good question. So, the question now is this. Caitlin asks, okay, what do you mean by entering a loop or leaving a loop? Okay, something like that. Let's say I do this. Not saying that's what it looks like, but let's say I did that. What I'm trying to reference is at 0, from 0 I went positive. So out of 0 I went positive. And then what happened potentially at 120? It goes negative. So then maybe that negative helps me flip into a new zone. And maybe that new zone is that. Now look what I did here. I guess it's at 120 I exited the blue loop and entered the red loop. And then the red loop finished where? At 180. So then it's almost like, another way to phrase it is, potentially in here I have a loop. 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 Now what I don't know yet about those loops are, is this a positive loop? Is this let me make it a little bit lighter, a negative loop? Is this a positive loop? Is this a negative loop? I don't know that yet. Could it be different varieties of it? Okay with that? So when I say kind of enter and exit, each spot exits a loop and enters a new loop. So I should just say it's a transition of loops. Okay? How's that so far? Okay? Now, I'm going to show you my new program. Okay? I made this, it's a merge of the two programs from yesterday. I was working on it all afternoon yesterday. Here's my guys. Okay? And I have the exact same, if I do a copy paste, here is the order. Sorry, edit, undo. Let's go with this. I want this order. Copy. On this part here, edit, paste. Okay. Here's the order that we had. Do you guys agree? Okay. And I was actually right on this. Do you understand what I highlighted a blue loop? Look at all of the sticks between 0 and 120. 0 and 2 pi over 3. Those are all blue loops right here. This is a blue loop, which then goes into a red loop, back to a blue loop, back to a red loop. You guys okay with that? Now, what I made on my program is I animated this. So it's basically me merging the two files. So let me show you how this is drawn here. Okay, so if I go to my my newest app, May 1st, if I click it, okay, what was the guy again? It was sine x, 2 cosine x plus 1. Sine parentheses. Okay. I'll turn off my quadrant. Okay, here's what I have. You remember yesterday when I slid A from 0 to 1, it showed you the polar. What I attached to this program is I stuck the sticks there so you can watch each stick move. So, like this here, watch every stick move. And I have a butterfly. Going back here, how many loops am I going to have? 4. A positive big loop, 2 small negative, or 2 small loops, and a big negative loop. Is there symmetry in my loops? The big blue one should be the same as the big red one. And the little red and little blue should be the same. This is from 0, 0 to 120. So in the first 120 degrees, I make a ginormous loop. So only look at the blue guy. Don't worry about the other three pieces here. Watch me make a big loop with that. Can you see that big loop of the blue? You guys okay with that? And that enters. Where does that, let me turn this into radians or degrees. Where does that big loop enter at? I'm zooming in on it. 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 I'm zooming in. Here's that black line. That's the loop. And if I take you to the origin, what's it coming in at? 2 pi over 3. Just like my picture told me. Now, where's this red one from? This one right here. Where's this guy from? 120 to 180. So between 120 and 180, I'm making a backward small loop. That is this pedal right here at 120. You know how I said it entered at exited the blue loop at 120 and now enters the red loop at 120. So right coming out of here, which way am I driving? I'm driving at that 120 out. You guys okay with that? And then when do I finish this loop? What, 180. Now go back to here. Now I'm at 180 to what? 240. Now it's a small blue loop from 180. Here's coming out at 180. And it enters back in at 240 to then finish off with the big other loop. I am not making you know that butterfly. You don't need to know that by heart. But do you think you should be able to know that there was 4 loops? Because could you find the 4 spots that it re-entered the origin? You guys okay with that? So now let's do one that I think you should get all by hand. So I want this guy. I want you to do R equals, let's do 6 sine theta. Let's go with minus 3. 6 sine theta minus 3. Yeah, let me make sure I like this. Yeah, try this one out. I want you to try and draw this including any loops or including any moment where it might go through the 0. Okay? So I'm going to hit pause for you guys to try this out. Okay. I will make sure you know how to draw this in rectangular. Okay? You should be able to draw what I drew on the left side for 6 sine theta minus 3. You should be able to draw that. Okay? That's regular pre-calc. That's trig. Baseline -3, up 6, down 6. Which 4 lines will I always grab? Always. To help you draw this. Which 4 am I always drawing? 0, 90, 180, 270, and I get 360. Okay? So do you see my orange stick here? My orange stick here is at 0, -3. What's the 0 represent in polar? The angle. I want to look due east, but it's -3, so I look backwards. Can you see in my polar picture how I dashed it? So I'm calling a dashed a negative look. So I want to look east, but I'm going backwards on the orange to the west. Then I do the teal. The teal's at the 90, and it's looking up at 3. So it's a solid 3 looking due north. There's my teal. The pink is another -3. So I want to look east, but I am actually west. And then the dark gray is I'm -9. So I want to look south, but I'm way back up north. That's what I have. Next comment. I looked at when do I go through the origin? Where do I have a pole? Where do I have a root? I did that in the yellow, and I get 30 and 1